today. So if you weren't here today, you can watch this lesson online and not fall too far behind. What is surface area? Let's just remind ourselves so that we know.
How much paint covers the wall?
Yeah, that's kind of the best way to put it, right? Like how much paint it takes to cover a wall or a surface of any sort. And it doesn't have to be paint. It could be anything. It could be how much wallpaper, how much flooring, how much whatever, how much carpet to cover something. But typically we do talk about paint. So it's just a reminder what we're doing is how much it takes to cover something. How much, I'm going to say just space it takes to cover a surface. Now, the other day, when we did this, we were talking about just like 2D images. That's like a one flat surface. So, for instance, if I said the top of this desk, how much would it take to cover just the top of that desk? You're looking at one 2D rectangle, nice and simple. Today, what we're going to do is we're going to think about like boxes and stuff like that. And be like, okay, now what if I wanted to cover this entire box? Not just the top. I want to cover the top, the sides, and the bottom. I want to paint the whole thing. Or I want to cover the whole thing. That's what we're going to do today. I think the best way to tackle these 3D images is to try to picture what they would look like if you unfolded it, if you broke it down into all of its layers. So this first picture, we have a box. Right? It's called a rectangular prism. But let's just call it a box because that makes it simple. And then beside the box, you have this weird picture. That picture is it unfolded, what it would look like if you cut out all the pieces. So for instance, this right here is the bottom of the box. And then part B is like this back sheet right here, if it would just fold it down. So this part right here is this back side. Part E is the front part. So as if it had been laid down, folded down. All the colors on top of each other doesn't go well. Part F is the top of the box. So as if this top layer up here. And then you have the two sides of the box. You have side A and side D. We'll say D is this side right here. And that's that side over there, side A. See how they've like unfolded it, right? And they've laid it all out. The reason it might help to try to take every side of an object and draw it like this is it helps you kind of keep track of every side. Because if you're wanting to do the whole surface area, you're going to have to know every single side. And it also helps you picture the image of what every side looks like. On a prism like this, you'll notice that every single side is a rectangle or a square. In this case, they're all rectangles. We don't think we have any squares. And we know we can calculate the area of a rectangle using our skills from the other day. So below, I have it labeled kind of nicely. The surface area of each individual little section. So for instance, the area of side A, this one little side over here.
Yeah. 15 centimeters squared.
Yeah, it would be 15 centimeters squared. So side A is this one right here. Let me do it in purple, which means it's this side over here. And we remember that area is length times width. If I look at this square, the length is 3, the width is 5. 3 times 5 is 15. And he said centimeters squared. We're going to do every single side. Right? That's our plan. I'll do side B next. If I was to look at side B,
3 times 8.
3 times 8, right? And it's even labeled still on the side there. I'm going to color it. It's that back side over here. The length of that is 8 times the height of that backside, which is 3, would be 3 times 8, which is 24 centimeters squared.
I'm putting that on C.
Oh, yeah, good catch. I know I can move this. Let's see how. Is that area B? Thank you. All right, let's try the bottom of this box. So the bottom of this box, right here, is going to be that. And yeah, you got it right. It's going to be 5, which is this length across, times 8, which is that width. 5 times 8 equals 40. And again, it's centimeters squared. Now, if you notice, when you look at these prisms, a lot of the sides are the same, right? They have like a matching pair. So, for instance, C, the bottom of the box, is the exact same thing as the top of the box, or in this case, side F. So if you want to just use the same numbers because it's the exact same size, that's fine. I can go to F and I can just fill it out. I can just say it's 5 times 8, which is 40 centimeters squared. I know they're the same, right? They match up. The top and the bottom are the exact same. If I look at the back side, which for us was B, I can recognize that B is the exact same as E. The front and the back are the exact same. So if I want to use the exact same numbers for E, 8 times 3 equals 24 centimeters squared, I can do that as well. And the sides, A and D, you'll notice, are the exact same as well. So if I want to just look at that box and be like, hey, wait a minute, that side and that side are the same, you can do that. If you would rather just calculate every single side and just look at it individually and be like, I don't want to worry about what's the same, what's not the same, hey, all the power to you. You're welcome to do that. Cool. Now that I've figured out how much it would take to cover all the sides, right? The top, the bottom, the front, the back, the sides. To figure out the entire shape, I just have to add all those parts together. So your last step is just going to be adding all those sides.
Doesn't it come to 240 centimeters squared?
I'm not sure. So you have 15 plus 24 plus 40 plus 15 plus 24 plus 40. You would get 64, 74, 79, 158 is what I get. Yeah. So if you add all those sides,
Oh, yeah.
158 centimeters squared.
Yeah.
Typically, people you'll do all these calculations, right? And then the adding goes wrong somewhere along the ways, right? It's a lot of numbers to be adding. It really does help if you label things out. So if you're like, these were all called A, B, C, D, E, F, right? You could label top equals this, bottom equals this, side equals this to keep it organized. Yeah.
What I did is for this one, all the sides like the same.
Yeah.
I just added like half them together and times it by 2.
Yeah, so you could do this.
Yeah, I did 80 plus 30 plus
and then times that by 2, right? So you did 15 plus 24 plus 40 times it by 2, and it gives you this other half over here. Yep, that works too. As long as the sides are the same, that trick works.
Yeah.
Yep.
So I got 80 plus 30 plus 40.
80 plus 30 plus 40. Yep, that's the same thing. So you just doubled it and then added those together. Yep, that's fine. As long as you see that they're identical, your guys' tricks of timing by 2 should work just fine.
Is there any easier way than just doing it in 5?
Honestly, Not really. You're kind of stuck always having to do all those calculations. Even when I'm making the answer keys for the practice book, I usually try to do whatever shortcuts I know. And there's really no shortcut to surface area. You just kind of got to grind it out a little bit, do the calculations. Unfortunately. If there was a faster way, I'd definitely show you. All right, they got one here. Calculate the surface area of the prism. You'll notice that they don't have everything labeled out for you this time. So they don't have like this is area A, this is area B, this is area C. So I'm going to do it the way that I would probably do it, which is I'm going to calculate the top first. The top is the exact same as the bottom. So I can calculate that one too. You can see those are identical. To do the top or the bottom, I'm doing length times width. My length is 8, my width is 5. So if I do 8 times 5, I get 40 meters squared. The bottom, since it's the exact same, would also be 40 meters squared. Yeah. Yeah, for sure. Looking at that guy. I now want to do the front of that box, which I know is the same as the back. Like just looking at it, those are definitely the same. The front would be this right here. I'm going to try to color it in for you. The front is our length, which is 8, times our width, which isn't labeled. You'll notice our width is like that height of the box. So somewhere on here, the height should be labeled. It's labeled on the back side of 6. So this would be 8 times 6. Which is 48, yeah. And again, that back side, which is back here, would be the exact same. The last two sides are the two sides of the box. Again, if you look at those sides of the box and you're trying to picture length times width, this is my length, it's 5. This height of the box is my width, which is 6. So I'm going to say the right side equals 5 times 6. The left side would be the exact same, 5 times 6. For 30 meters squared. After you do this, you're always going to have to do a total. You're going to have a lot of numbers on your page on a quiz or an assignment or anything like that. So make sure that you write it nice and clear for me where the total is. Try to put a box around it so I mark the right thing. You don't want me marking something else, right? Your total is all those numbers added together. So if I do 40 plus 40, right, that's the top and the bottom, plus 48 plus 48, that's the front and the back, plus 30 plus 30. 236 is what you got?
Yeah.
So I got 40, 88, 118, 236? Is that what you said?
Yeah.
Okay, good. I thought you said 46 for a second. 236. I agree with that. That sounds right to me. Again, make sure you box that in so that I know which answer is yours. Perfect. Before we go into the next one, I want to talk again because it helps to remind us of what this means. Like meters squared. What that means is this box, if you wanted to cover the whole thing, if you took square meters, so a square meter would mean this is 1 meter, make a square out of that meter. Cool. I'll try to do this as square as I can. Make a square meter. Oh, no. That's as good as square meters I'm going to get. It would take 236 of these to cover the box. That's what it means when you're talking about area. Right? And that's what the units are talking about. So you can imagine that box would be massive. Right? If I had 236 of these, that's a big box. If I was doing millimeters, that's very tiny boxes. Right? That's how many it would take to go on top of something. All right, we got one right there. We'll do one more together, and then the next one I'll let you guys kind of try on your own. We'll see how it goes. So you got this prism. You want to break it down into its parts. The first thing I always like to calculate is the top and the bottom. I don't know why, that's just where I like to start. So if I look at the top, I recognize that this top up here is the exact same as this bottom down here. So they're going to be the same numbers.
They're not in meters or anything.
Yeah, there's no unit there. Do we want to give it a unit? All right, we'll just leave it. Yeah, I'm with you. Let's say it's 10, 4, and 6 somethings. So if I'm looking at this, the bottom, I want to do length times width. That's 4 times 10. It's hard to see, but that is a rectangle down there. So we're going to do 4 times 10. That would give me 40 and 40. The next sides I'm going to do, I'm going to do this front piece right here. I'm going to call it the front. And this back piece back here. I recognize that those are the exact same, right? They're almost squares, right? If I want to do the area of this front guy, I want to do length times width. The width is not labeled, right? But it is the height of that prism. So somewhere the height of that thing must be labeled. It's labeled over here as 6. So I recognize it's 4 times 6. Again, front and back, they're the same thing. So it should be 24 and 24. The last two that I'm going to do, I'm calling them the sides. Probably could have called it front and back as well. So you got that side right there. And I call that the right side. And I have this left side back here. I recognize that they are both the same. When I go to calculate it, I want to do length times width. And so length times width. For me, that's going to be 10 times 6, which is 60. Your final job is always to add it all back up. So if I'm looking at this, I'm going to say the total surface area is 40 plus 40 plus 24 plus 24 plus 60 plus 60. You should get 248. Beautiful. I see some people nodding. That helps me out.
I got that.
Sweet. And I know units, so it can be whatever you want.
Yeah.
But chicken squared. Yeah, we'll go with that.
This one was confusing. It's all same sides.
The next one. Yeah,
So
the
I
next one's
did
hard.
5.6 times 3 like 4 times.
I think that's right, though.
And then I just times it by 2.
Okay, last one. Yeah. Times it by 4 is going to be right for those sides. Yeah. So if you look at this, you'll notice that we have like the top, the bottom, the front, the back, the left, the right. Because the top has all these little lines, that means all those are the same. So the top and the bottom are actually squares. So that is a square, and that is a square. Because the top and the bottom are squares, that means that all the sides are actually the same. So this front side is going to be the exact same as this right side, which I can't draw right now, which would be the same as the back, which would be the same as the left. So if you're doing the multiplication trick, you're going to times by 4, and you get all 4 sides right away, instead of having times by 2. If we're doing this my way, which is maybe a little bit slower, I would do the top first, and I recognize it's the same as the bottom. Because it's a square, that would be 3 times 3. So the top is 9 centimeters squared. The bottom is 9 centimeters squared. Then I have the front, which is the same as the back, which is the same as the left side, which is the same as the right side. They're all rectangles that are the same. If I want to calculate that front, I'm going to do length times width. So if I'm looking at this front here, length is 3. The width is the height. In this case, it's 5.6. So that would be 3 times 5.6. Which is a number I can do. Maybe 16.8. I don't trust myself on that, so I'm going to use calculator. 16.8? Yeah. Perfect. I like that you guys are nodding to me. I need your help. Again, front, back, left, right, they're all the same. So I'm just going to put them all the same. I can kind of skip that having to show the work. I just know they're the same. They're all 16.8 centimeters squared. Your final job is always to total it up. That'd be 9 plus 9 plus 16.8 plus 16.8 plus 16.8 plus 16.8. You throw that in your handy dandy calculator. You should get 85.2 centimeters squared. Got it right? Wrong? Did you use 16.8 times 4?
Yeah.
Yeah, and then did you add?
Not times 4. I did 16.8 times 2 times 2 times 2. I forgot the 2 times 3.
Oh, the top and the bottom, and then times that by 2. Okay. As long as you can recognize where it went wrong. Awesome. That's the surface area of a box, which the technical term is like a prism, right? A rectangular prism because the sides are rectangles, or in this case, a square prism because the sides are squares. I just call it a box. It's just easier. That's what it is, right? It's a box. We're going to practice So I'll give you some time to do some on your own. Make sure you're getting it right and that we got it down. Then we're going to do cylinders. So cylinders when you have circles on the top and the bottom. A little bit harder, not too crazy. On Thursday, we're going to do more shapes. I can't remember which ones we do. I think we start doing pyramids and spheres, so balls, and something else. I just can't remember. Awesome. I'll hand you out your practice sheet. Is like a coffee cup, like this cylinder, right? Something round around here with a circle on the top and a circle on the bottom. I guess I should do that proper. Circle on the top, circle on the bottom. Yeah.
Can I say the formula for it?
Yeah, hit me up. So the formula for doing the surface area of a circle.
2 pi r squared times the length.
Beauty.
Or length at
Circles would be 2 pi r squared. Perfect. And then you got to do the middle part, right? I like to call it the label. So like if you pretend you have this and you had that label around it, right? And it's a rectangle, which you say you'd have to add. So that label always forms a rectangle, which we know is length times width.
And the width would be the diameter.
Yeah. And that's the tricky part, right? So with this rectangle, figure out what is the length and what is the width. So when you unfold it, so you have this beautiful label around here. Let's see if I can do it. Got a label around my coffee cup. Oh God, I don't have a lid on my coffee cup because I lost it. Like the third day I got this coffee cup. So you have this label, right? If you were to unfold it, it creates that rectangle where the width is the top here. That was equal to the circle on the top. And it's not the diameter, it's not the radius, it's called the circumference, right? So the top around the circle is your length. The width is the height of that label. So if we're thinking length times width, for these cylinders, we would actually say circumference times the height of that cylinder. Circumference being around the circle. And so all these questions are going to have to give you around that circle. Beautiful. For these circles, we just said 2 times because there's always going to be 2 circles, the top and the bottom. If there wasn't 2 circles, so for instance, my coffee cup doesn't have a top, then I wouldn't do the 2 anymore. I would just do pi r squared for the 1 circle. So if that's a circle that is open-ended, you wouldn't have the 2 anymore. Let's try some questions. Best way to do math is just to do it. Calculate the surface area of the cylinder. We'll start with the circle part because we can do the circle part easy. Then we're going to try to do the label part, and we're going to run into a bit of a problem. Okay, so let's start off. How do you do the circles? So the top and the bottom. Top and the bottom right here. You're doing 2 pi r squared. R is the radius, right? That's from the center of the circle to the outside edge of the circle. That's R right there. So I want to do 2 times pi times 1.5 squared. If you put that in your calculator, remember especially if you're using your phone calculator, make sure you're doing the squared part first. So 1.5 squared, then times pi, or 3.14, then times 2. And you'll get 14.137 and then a bunch more numbers. That gives me the top circle, bottom circle. Now we want to do that label. This part. It is a rectangle when you unfold it. Your formula is circumference. I'm just going to put circ times height. If you look at this question, they don't tell you what the circumference is. But they do give you the radius. So somehow we're going to have to connect radius to circumference. And remember, circumference is different than diameter. Diameter is across. So if you had this, diameter is from here to here. We want circumference. Circumference is all the way around. Right, so that's different. There's a formula for circumference. I'm having a moment of I don't think I have it right, so I'm going to make sure I Google it. So circumference of a circle is equal to, not equal to r, it's equal to 2 pi r. Yeah, it is. Right? It doesn't say that on Google, but I'm positive it's 2 pi r. Yeah, we're going to go with it. So this part right here, the circumference, if it's not given to you, is 2 times pi times r. And honestly, it's probably not going to be given to you very often. So you're going to have to use that formula to figure out that part. Awesome. So now that I can go into my rectangle, the circumference is 2 times pi times 1.5. Then I can multiply by the height, which is 4.1. So I have 2 times pi times 1.5 times 4.1. That will give me the area of my rectangle. 2 times pi times 1.5 times 4.1 equals 38.641, and then a bunch more decimals. And I now have my two parts. I have the top and the bottom, the circles, and I have my label around the outside. If I want to do my total, I add those parts together. So I do my circles, 14.137, plus my label, 38.641. You should use all those decimals that we had. And we are going to round to be 52.8 millimeters squared. Cylinders are hard, right? You have to first be able to picture what it looks like. And then second part is getting that label, the height and the width is not easy. And it has little tricks to it. I'll let you write that down so people are still going to jot notes to themselves. All right. We'll try another one. So we've got a cylinder. This is a big cylinder. It looks so it's like a little chubby one. So if we look at that, the first thing I recognize, they gave me the diameter, right? All the way across the circle. And I don't want to use the diameter. I want to use the radius for all my formulas. The radius is this divided by 2. So you need to go 5.2 divided by 2 to figure out what half of that is. When you do that, you get 2.6. Remember, we use radius for like all of our formulas. So when you get diameter, just cut it in half and then do the radius. Awesome. We're going to calculate the surface area of this cylinder. We're going to start off by doing the circles, so the top and the bottom. The circles is 2 times pi times r squared, like what Josh told us. That would be 2 times pi times 2.6 squared. If you're using your phone for a calculator, make sure you do the 2.6 squared first. then times by pi,
So if you're using
times by
your
2.
phone, do you do 2 and then pi?
You go times 2 and then times pi, and that would work. Yep. So you can do it all in separate steps, and that'll be fine. 42.474 ... right? It keeps going. Sorry, I keep running out of space there, so it's a little bit jammed in. It's 42.474. The hard part is that label. I'm actually just going to name it label so people know what I'm talking about. It's that rectangle, right? To do the length and the width of that. The length is the circumference. The width is the height. Circumference is 2 pi r. The height is 4.3. I'm just going to leave it as h for now. Then you can put all your values in, right? Once you recognize what your formulas are, you can put everything else in. So 2 times pi times 2.6.
Do you have to do that first, or can you just do?
You could just go straight to the numbers.
Can you go 2 pi r times height?
Yep.
For your first step.
Yep. If you just want to jump right to it, that's fine. Yeah. I'm just showing the steps in case someone's like, whoa, where's he getting those numbers? When you calculate all that, your label will equal 2 times pi times 2.6 times 4.3, 70.246. And then again, ... Like there's more to it. So I have my area of my circles. I have my area of my label. If I add them together, that will be my total. My computer is lagging. Oh no. So 42.474 plus 70.246. Computer can't keep up with the math we're doing. Your answer would be 112.72. We're just going to do 0.7. And that was feet squared. Yeah. Of course. How do you feel about these cylinders? A little harder, right? Like the circumference part is definitely the hardest part, in my opinion. But there's just so many little pieces to it, right? Like that's what makes it hard. All right. There's one more there. I'm going to give you a minute to just try it on your own so you can see where you get stuck, because you're going to get stuck and that's fine. And then you can kind of like self-evaluate, be like, okay, I need to remember that for next time. So give it a shot the best you can right now on your own. 2 times pi times 3.8 squared. Right, so we divided our diameter in 2 to get the radius. Then I can use my radius in my calculation. My circles. Again, you might just want to do 3.8 times 3.8 in your calculator to make it easier instead of doing 3.8 squared, because sometimes that squared button is weird. It depends on the calculator, yeah. Like it's in weird spots sometimes where it'll be like a y with an x as the exponent. And yeah, so then you have to put a button to be a button, and it's weird. So sometimes it's easier to do it by hand. But you should have got 90.729 for the circles. ... So far, so good? Beautiful.
Do we have to put the third decimal? Do you have 3 decimals or 2?
Try to carry 3 till the very end, just to save your butt a little bit in case you need to round it. For the label, we know the label is the rectangle, which is circumference, that's the top circle, times the height. Circumference is 2 times pi times radius. And then height is just the height. If we put that in our calculator, it's 2 times pi times 3.8 times our height, which is 4.4. Our height isn't, it's weird because it's laid down, right? So you got to kind of imagine if you stood that up, the height would be 4.4. Sorry, it's so fuzzy. That's our good internet up here and our good computer here. You throw that in your calculator, 4.4 times 3.8 times pi times 2, 105.054. Still good? All right. The last thing you got to do is add it up. So you're going to do 90.729 plus 105.054. I ran out of space. Your final answer should have been 195.8 after you round it. It was actually 7.8. If you put 7, I'd give it to you. So 195.8 after I round it, and it's inches squared. Now you got surface area of a cylinder. Killed it. I won't see you guys again until Thursday.